In this video, we're going to discuss the different types of shapes of distributions. We've already discussed histograms of discrete and continuous data. Well, now we want to look at those histograms and describe their shape. There are certain types that we actually described. The first one is what we call a uniform distribution. In this uniform distribution, what it means is that the frequency of each variable is evenly spread out across the values of the variables. So that uniform, it looks more like this, where they're all about the same height. It's a uniformity across the top. They all have approximately the same frequency. The next one that we're going to look at is what we call a bell-shaped distribution. For the bell-shaped distribution, it looks similar to a bell. It's symmetric, and this is a key, is it's symmetric distribution, which the highest frequency occurs in the middle, and the frequencies tail off to the right and left. So in this case, it's going to look something like this. I'm not a very good artist, but notice how this side over here, if I draw a line down the center, I can fold it over on itself. Bell-shaped is just that. It looks like a bell, and it is symmetric. That is another shape that we look at, is symmetric. Now, here's the thing. Every symmetric is not necessarily going to be a bell-shaped, okay? Bell-shaped distribution means that the highest values are here. Symmetric, it just means that they're the same on both sides. So for a symmetric, it could look something like this, and then go back up. Notice this one is symmetric. If I draw it down the center, I can still flip those two sides over upon themselves. The bell-shaped is symmetric because if I flip this side over to the other side, then it's on top of itself. Just because something is symmetric does not necessarily mean that it's bell-shaped, because of the fact that I could draw it with the lowest frequencies in the center. And that's what the bell-shaped is, always going to have the highest frequencies in the center. The other two types of histograms are what we call skewed. So there are different types of skewed data. The first type is a skewed right distribution. And if you'll notice and I'm misspelling that again, so let me start over. So there we go. So a skewed right means that the tail is to the right and the taller, longer frequencies are to the left. So it's going to look something like this, and then it's going to taper off to the right-hand side. If we're looking at a histogram, it could look something along these lines. Notice there's more of, say, a single or smaller bars on the right side. That is a skewed right distribution. Flip side of that is a skewed left distribution. Well, if a skewed right distribution has the tail on the right side with the taller frequencies on the left, a skewed left distribution is going to be just the opposite. So it's going to look something along these lines. Okay, notice you have the smaller frequencies on the left side. So let's look at some actual examples of this. And here is our uniform distribution. Notice it is symmetric, because of the fact that I can take and cut down the center and then fold this distribution over itself, and therefore it would be on top. It wouldn't be overlapping or anything of those lines. Now the bell-shaped, remember, is symmetric, so we have symmetric down here, but the tallest frequencies are in the center where you have your lower frequencies on either side. Now here is a skewed right. Notice that we have this tail over here with the smaller frequencies. This one is a skewed left. The frequencies are maybe larger, but they're still smaller than this other side. And I can't take half of this and flip it over on itself to make it a bell-shaped or anything. You'll notice that I have the taller peaks on the right side for the skewed left, and the opposite side for the skewed right. So we had already drawn the histogram for our time between eruptions at Old Faithful, and it looked something similar to this. Now our possibilities are uniform, bell-shaped, left skewed, or right skewed. These are our different possibilities when we're describing the shapes. If we look at this, uniform means for it to be the same height all the way across. Well, that's not the case because look at these two values. So it's not uniform. Bell-shaped means that the highest peaks should be right here. Well, the highest peaks are definitely not there, so it is definitely not going to be a bell-shaped. If we look at this, we'll notice that we have a high peak here on the right side and a lower parts on the left side. Lower parts is where our skew is, so this is going to be skewed to the left. So you're always looking at where those lower values are. So a peak or high point of a histogram is also referred to as a mode, meaning it's the most frequent. It has a higher frequency than any of the others. A histogram is unimodal if only has one mode, and it's bimodal if it has more than one distinct mode. So let's look at these three different histograms here. You'll notice on this one, I definitely have a massive peak right here. So this bar would be considered my mode. Now looking at whether it is skewed to the left, skewed to the right, or approximately symmetric, notice I have this tail over here that have really low values and a higher value here on the left-hand side. Because this tail is on the right side, this is going to be right skewed, or skewed to the right. Now looking at part B of this example, again I have a unimodal because I have one tall peak. So this is my mode. And I have this lower end down here on the left. So this is going to be skewed to the left. Now looking at this last histogram, you'll notice that I have these two peaks here, and then it starts tapering off to the other sides. I could start looking at, okay, is this going to be, notice these two are my middle two. So since my taller ones are in the middle, this is going to be approximately symmetric. You could say bell-shaped on this one because it does have that bell-shaped. Notice I put approximately symmetric, and that's because of the fact that it's not exactly symmetric because I don't have that single highest value right in the center. So it's not completely symmetric or anything. Now, for my mode, I do have actually a single mode because you'll notice that this one is slightly taller. So this bar of my histogram is my mode. So I'd like for you to practice working with the different distributions and seeing if you can identify whether they're right skewed, left skewed, approximately symmetric, bell-shaped, and then let me know if you have any questions.